Environmental collapse and genetic fragility met superior social networks and technology.
I want you to just close your eyes for a second. We're going back 40,000 years. You're on a ridge, somewhere in, say, Central Europe. It is the deep ice age. And the wind that's cutting through your furs, it isn't just cold, it's arched. It's ancient, bone-chilling. And below you, in the valley, you can hear the rumble of mammoths, maybe a woolly rhino. But if you look closely, the most interesting thing out there isn't the wildlife. It's the people.
Because right at this moment, at this very specific point in history, there isn't just one type of human trying to survive. There are two.
Right. You've got the locals, the Neanderthals, stocky, incredibly powerful. They've been the masters of Europe for hundreds of thousands of years, built like tanks. And then you've got the new kids on the block, us, Homo sapiens. We're just filtering in from the south, looking, probably a little flimsy by comparison.
It's a completely unique overlap in our evolutionary history. But here's the mystery, the thing that's kept archaeologists up at night for decades. Within just a few thousand years of our arrival, the Neanderthals, they just vanish. They survive brutal ice ages, massive predators, and then all of a sudden, they're gone.
And for the longest time, the story we told ourselves, or at least the one Hollywood loved to tell, was pretty dark. It was this sort of Cain and Abel narrative. We, the superior intellects, marched in with better spears and just wiped them out. A prehistoric war.
That was the dominant idea for a long, long time, this concept of a violent replacement, maybe even a genocide. But today, for this deep dive, we're looking at a whole stack of new research from genetics, archaeology, geology, and some really cutting-edge climate modeling that completely flips that script.
So the mission for us today is pretty simple. Did we actually kill the Neanderthals, or did the universe just kind of conspire against them?
It's a fascinating detective story. And when you look at the evidence, especially from some recent modeling studies, the answer isn't a single smoking gun. It's what scientists are now calling a multi-causal mosaic.
A mosaic? I like that. So it wasn't just one bad Tuesday that did them in. It was more like a perfect storm of bad luck.
Precisely. We're going to look at this from three different angles today. First, what we could call the internal enemy, genetic collapse that was happening inside their population long before we ever showed up. Second, a massive geological catastrophe that literally rocked the continent. And then finally, the sapiens ed, or the specific tools and social habits we had that they didn't.
Okay, let's unpack that. I want to start with the Neanderthals themselves, because I think that popular image, the rugged, unkillable caveman, is still so strong. If you survived 300,000 years of the Ice Age, you must have been doing something right. But the sources suggest that by the time we arrived, they were already kind of walking dead.
Walking dead might be a little dramatic, but demographically, yeah, they were in serious, serious trouble. If you look at the population data from before Homo sapiens got to Europe, so around 45,000 years ago, the Neanderthals were already spiraling.
What does that look like on the ground? A population crash.
We're talking about density, or really the lack of it. Neanderthals lived in these extremely small bands, maybe 20 adults, sometimes fewer. And these little bands were scattered across huge distances, totally separated by mountains and ice sheets.
So no villages, no trade hubs, just lonely families in a frozen nowhere.
Exactly. And that kind of isolation creates a biological time bomb.
Inbreeding.
Inbreeding, yes. The genomic studies from the last few years are just brutal on this. They show this really high level of what they call mutational burden in the Neanderthal genome.
It means they were mating with close relatives just to keep the group going.
Yes, and when your gene pool gets that shallow, harmful mutations, don't get filtered out. They just pile up. The data suggests this could have slashed their fertility by as much as 40%.
40%. That is a massive number. I mean, if you're losing 40% of your potential next generation, you're not growing, you're shrinking fast.
And that brings us to this really key ecological concept. It's called the Allee effect.
I saw that in the notes. It sounds like a magic trick, but it's pure ecology, right?
It is. The Allee effect basically says there's a critical threshold for population size. If a group gets too small, the individual fitness of everyone in that group just plummets.
Wait, so it's not just that there are fewer people, but the people who are there become less effective at everything.
Exactly. Think about Stone Age logistics. If you only have 10 adults and 3 get sick or break a leg, who's going to hunt? Who defends the cave from a predator? Who looks after the kids? In a tiny group, a bit of bad luck becomes fatal. You can't hunt a mammoth with 3 people.
So they were caught in this vicious cycle. The smaller the group gets, the harder it is to survive, which just makes the group even smaller.
And this is where the new modeling gets really interesting. These 2025 models, they ran simulations on this exact problem. They wanted to know what it would take to drive them to extinction without any kind of war with us.
Just based on the cold, hard math of survival. And what did they find?
They found that a decrease in infant survival rates of just 1.5% was enough.
1.5%. That sounds like a rounding error. Surely a species can handle a 1.5% dip.
Normally, yes. But because their numbers were already so low and so fragile, that tiny dip, 1.5% fewer babies making it to adulthood, was enough to doom the entire species within a few thousand years.
That is just a terrifyingly thin margin. So technically, we didn't even need to show up. They might have just faded away on their own.
The evidence from places like Iberia seems to back that up. We see Neanderthal remains that are genetically isolated, struggling, long before sapiens are on the scene. But they might have hung on. You know, populations can bounce back. Nature finds a way.
But they didn't get the chance. Because right when their genetics were crumbling, the planet decided to throw a curveball.
A massive one. We need to talk about the Campi Flegrei eruption.
Okay, so I know Vesuvius, the Pompeii one. Is this related?
It's in the same neighborhood, yeah, the Phlegraean fields in Italy. But the scale it's not even comparable. This is the Campani Ignimbrite eruption. Around 39,850 years ago, Vesuvius was a firecracker. This thing was one of the largest volcanic eruptions in Europe in the last 200,000 years.
Okay, paint me a picture. I'm a Neanderthal in Europe. What do I see?
If you're anywhere near Italy, you see the end of the world. It spewed something like 300 cubic kilometers of ash and rock. This column of smoke just pierces the stratosphere. And that ash didn't stay in Italy. It blanketed the entire continent. In some places, thousands of kilometers away, you'd have a 10-centimeter thick layer of ash on the ground.
Ankle-deep sludge covering everything. That must have killed all the grass.
It kills the vegetation, absolutely. But the real killer wasn't the ash on the ground, it was the sulfur in the air. It triggered a volcanic winter.
Which means it blocks out the sun.
Right, and global temperatures dropped by 2 to 3 degrees Celsius.
Okay, let me play devil's advocate for a second. We talk about climate change today, and we panic over a 2-degree rise. But a 2-degree drop, does that really equal apocalypse? It just sounds like you need an extra fur coat.
That's a common reaction, but you have to remember the context. This is already the Ice Age. The world is already fusing. And this eruption happened right on top of another cooling period called Heinrich Event 4. Icebergs were already choking the Atlantic.
So the thermostat was already turned down to freezing, and the volcano just cranked it down to absolute zero.
Pretty much. And that causes a trophic cascade. The plants die from the ash and the cold. Then the herbivores, the bison, the mammoths, they starve or they migrate. And the Neanderthals, who are these top-level carnivores, totally dependent on that big game, they starve too.
The whole house of cards just collapses. Do we have physical proof of this, or is it just a theory?
Oh, we have proof. You can look at sites like Grotta del Cavallo in Italy. The archaeology there is like a layer cake. You have the Neanderthal layer with tools, bones, life. Then you get this thick, sterile layer of volcanic ash. And above the ash,
Nothing.
silence. No more Neanderthals. They just vanish from the record in those blast zones.
So was that it? Did the volcano just blast them all into extinction?
Well, biology is always messy. The sources highlight something called distal refugia.
Which is just a fancy way of saying safe zones, right?
Basically, yeah.
Oh.
If you were far enough away, say on the Iberian Peninsula in Spain, you survived the immediate effects. And we know Neanderthals hung on in those refuges for thousands of years after the eruption.
Okay, so the volcano knocks them down, kills off the populations in Italy and Eastern Europe. But the Spanish Neanderthals are still standing.
Standing, but incredibly stressed. Their networks are shattered, their food is unstable, the climate is chaotic, they're just barely hanging on, and that is when the third factor comes into play.
Enter Homo sapiens.
Enter us.
So we've established we didn't necessarily wage some big war. But we clearly survived this perfect storm better than they did. Why? What was the sapiens' edge?
Well, if you just contrast the two populations, it's striking. We already mentioned the small, isolated Neanderthal bands. Sapiens, on the other hand, we had networks.
Social networks.
Huge ones. We lived in larger groups, sure, hundreds strong. But the important thing is we were interconnected. We have archaeological evidence of flint trade networks that span over 300 kilometers.
300 kilometers. In the Stone Age. That's an insanely long way to move a rock.
It is. But think what that really represents. It's not just about trading a rock, it's an insurance policy.
Oh, so?
If a group in one valley was struggling, maybe their local herds died off, maybe because of the volcanic ash. They could rely on their neighbors. They could trade for resources or even move in with relatives in a different territory. They shared information. Hey, the bison have moved south, or here's a new way to have to spearhead.
That is a massive advantage. If you're a Neanderthal and your valley gets buried in ash, you're stuck. You don't know anyone over the next mountain range. You have nowhere to go.
Exactly. Neanderthals were locally adapted, but they were socially isolated. We were, in a sense, globally connected. And there's a site, Glacial Cave in Greece, that's a perfect example. It shows an unbroken record of sapiens living there, even right through the ash layers. We didn't leave, we adapted.
And a huge part of that adaptation was technology. The sources talk about a creative explosion around this time.
This is the Aurgnation culture, and the technological leap here is just immense. Neanderthals were using their Mousterian tools, which were effective, don't get me wrong, but they hadn't changed much in huge spans of time. They were in these Mousterian ruts.
And what were we doing differently?
We were innovating constantly. We started making blades from prepared cores, which is a much more efficient use of stone. But the real game changer wasn't stone, it was bone.
Why is a bone tool such a big deal?
Because with bone, you can make a needle.
A sewing needle. That sounds so aesthetic.
It sounds mundane, I know. But in an ice age, a needle is high-level survival tech.
Oh.
A needle means you can sew fitted clothing. Before this, you're just draping hides over yourself, maybe tying them on. But with a needle, you can tailor pants, sleeves, a parka that fits tight to your body.
Which traps body heat much more efficiently.
Exactly. It creates this personal microclimate against your skin that lets sapiens be active in colder temperatures for longer. You burn fewer calories just staying warm. It's a massive metabolic advantage.
That makes total sense. It's the difference between wearing a blanket and wearing a modern thermal ski suit.
And then there's the weaponry, the atlatl, the spear thrower.
Right. This is the stick that acts like a lever to launch a spear much faster and farther.
Yes. It essentially extends the length of your arm. It lets you throw a projectile with lethal force and high accuracy from a safe distance.
And you compare that to how Neanderthals hunted.
Neanderthal skeletons are just full of healed fractures, broken arms, smashed ribs, head trauma. They were ambush hunters. They had to get right up close to a giant bison or a mammoth and jab it with a heavy spear. That is incredibly high risk.
So every single hunt is a roll of the dice on whether you get gored.
Exactly. We could stand back and throw. Safer hunting means fewer injuries, which means longer lives and more children. It's a statistical edge that just compounds over generations.
And then you have the art, the cave murals.
Chauvet Cave, around 36,000 years ago. This isn't just doodling, it shows a symbolic mind, a brain that's wired for abstract thought, for complex communication. That kind of cognitive firepower is probably what allowed us to maintain those big social networks in the first place.
So yeah, better gear, better clothes, bigger networks, safer hunting. It really does just feel like we outcompeted them.
That is the leading theory now. It's called ecocultural competition. We didn't need to kill them in battle. We out-hunted them and outbred them. We took over their ecological niche.
But let's talk about the interaction. Because we know we didn't just walk past each other. We met.
Oh.
And we mingled.
We did. And this is really the final piece of the puzzle, the verdict, if you will.
The genetic dilution.
Right. We know for a fact that interbreeding happened. Most people today of non-African descent have about 1 to 2% Neanderthal DNA in their genome.
Which, by the way, gave us some good stuff, right? Like immunity boosts.
It did, yes. Some of those genes helped our immune systems adapt to Eurasian diseases. But from the Neanderthal perspective, this interbreeding might have been the final nail in the coffin.
How so?
Just think about the numbers again. You have this massive wave of thousands upon thousands of Homo sapiens moving in, and you have this tiny, shrinking, fragmented population of Neanderthals. If they start mating with us, their distinct genetic lineage just gets swamped.
It's like pouring a cup of red dye into a swimming pool. The red just disappears.
That's a perfect analogy. The latest mathematical models call this a slow fade. It's a process of absorption. The Neanderthals weren't so much killed off as they were bred out. Sapiens diluted the Neanderthal genes through recurrent mating over thousands of years.
That is such a different image than a war. It's almost gentle in a very tragic way.
It is. The pure Neanderthal lineage crumbled because of demographics. That was the internal enemy. The catastrophe kicked them to the breaking point, and then we arrived with the sapiens' edge and just absorbed what was left.
So to sum up this multi-causal mosaic, Neanderthals were already struggling with low numbers and bad genes. Then the Campi Flegrei supervolcano hits, starving their ecosystem. And finally, we show up with our needles, our trade routes, and our sheer numbers, and we basically just assimilate them.
That's the most accurate picture we have today. It wasn't one thing. It was this complex interplay of genes, geology, and ingenuity.
It really makes you think about what survival of the fittest actually means.
Yeah.
It's not about being the strongest physically. I mean, a Neanderthal is much stronger than one of us.
Oh, much stronger. If you arm wrestled a Neanderthal, you would lose. Every time. But survival favors the flexible. It favors those who can connect, who can adapt, who can rely on each other when the world turns against them.
It's a powerful takeaway. We're the descendants of the adaptable ones.
We are. And in a way, so are the Neanderthals. They do live on in that 1 or 2% of our DNA.
Here's a thought to leave you with. We often look at Neanderthals as some kind of failed experiment, a dead end on the evolutionary tree. But they lasted for 400,000 years. Our civilization has only been around for a tiny fraction of that. So if they were absorbed into us, did they really go extinct? Or did they just become us? As we face our own global challenges today, it's worth remembering that in the great game of survival, raw power often matters less than connection and the ability to adapt.
Well said.
Thanks for joining us for this deep dive into the Neanderthal enigma. Stay curious, stay adaptable, and we'll catch you on the next one.